To week 8 problem solving session for the NPTEL course on environmental impact assessment. The course instructor is Dr. Harshit Soshin Lagda, who's an assistant professor at the Department of Architecture and Planning, Indian Institute of Technology, Roorkee. I am Isha Rathore PMRF and research scholar from the Department of Architecture and Planning, Indian Institute of Technology, Roorkee. So a few housekeeping rules before we start this presentation. So please mute yourself for the session. If you have any questions, you can post them in the chat box. And at different points, I will ask you if you have any questions. You can then raise your hands and unmute yourself for asking questions. Okay, so this outline of the session is first we are going to look up at the highlights from each of the week, where we will look up at the key takeaways from each of the lecture unit. And we will also look up at assignment questions and solution to assignment questions with explanations and additional question and answers for practice based on week 8's content. And lastly, if we received any queries from you based on this week's content in the discussion forums, then we will also address them towards the third part of the session. Okay, so let's start. So week 8 looked up at the impact management, that is the mitigation and preparedness of environment management plans or EMPs. So let's look up at the highlights from week 8. So week 8, the first lecture was lecture 36, which looked up at EIA methods for climate and climate change part 2. This is in continuation to lecture 35, which also looked up at climate and climate change. EIA methods. So in this, we looked up at scoping and baseline studies, that is scoping for climate change mitigation. So we have several policy frameworks for climate change, which have defined the nationally determined contribution or the NDCs. So these are at the heart of the Paris Agreement and the achievement of these long-term goals. So each country pledges or attempts to reduce their national emissions and adapt to the impacts of climate change. So towards that aim, they have established their own nationally determined contributions or NDCs. So based on the country, the NDCs can be different. So, so for example, for the European Union, they have made commitments to reduce carbon emissions by 80% by 2050. So that is their NDC. Then for UK, they have a different NDC that is again based on what the UK government thought was the correct NDC. So while doing scoping for climate change mitigation, there are 4 key questions which we need to ask, and these are defined by the IAIA. So these are first, the proposal will directly or indirectly increase or decrease the greenhouse gas emissions. Second, the proposal may be beneficial or adversely affected by vulnerable to climate change, either directly or indirectly. Third, climate change may affect other aspects of the environment that are potentially affected by the impacts of the proposal. And fourth, an objective of the proposal is to use impact assessment to identify alternatives and measures to mitigate and or to adapt to climate change. So for scoping and baseline studies, we further look up at the preliminary scopings of greenhouse gas emissions. So we have adapted this from the CAAA 2003. So we have certain questions, and under each questions we also discuss the examples that these projects can prompt to question. So for example, when you have a proposal, you can ask questions like, is this project likely to generate significant volumes of greenhouse gas emissions during any phase of the project? So it could be including the exploration, construction, operation, or decommissioning. So especially projects like your coal-fired generating plant or your hydrocarbon production plant or some large-scale industrial manufacturing setup like a potential petroleum refining system or the cement-based industry or cement-based development, pulp and paper kind of development, iron and steel industry related proposal or chemical production related proposal. So these kind of projects are more likely to have this sort of question. You need to ask this kind of question whether it's going to lead to the generation of greenhouse gas emissions at any stage of the proposal or the project development. And based on that, you can then do further mitigation measures and adaptation, basically. Another question could be: is the project's construction or lifetime operation likely to adversely affect areas that may serve as carbon sinks for greenhouse gas emissions? Now, carbon sinks can be, for example, forests, crops, peatlands, and wetlands. So, if your project leads to large scale deforestation or large scale flooding of land or large scale changes in land use, so these are projects which are going to have an adverse effect in terms of reducing the carbon sink areas which are available for greenhouse gas emissions absorption. So, this is something that these kind of questions and putting them in the correct, measuring them in the correct matrix can help you. So we also looked up at COP26, which was the 26th Conference of Parties. So in this, Indian Prime Minister Narendra Modi, he declared a five-fold strategy, which was termed as the Panchamrit, to achieve our national determined contributions or NDCs. So these 5 points include: India will get its non-fossil energy capacity to 500 gigawatt by 2030. India will meet 50% of its energy requirements from renewable energy by 2030. It will reduce the total projected carbon emissions by 1 billion ton from now onwards till 2030. And by 2030, India will reduce the carbon intensity of its economy by less than 45%. And by the year 2070, India will achieve the target of net zero. This was the main uh, commitment that we have promised to make. So these are our NDCs, India's NDCs. Then scoping for adaptation can include like agreement with key stakeholders on the most appropriate climate change projections to adopt for assessment and any necessary methodological considerations. So the stakeholders are also having their voice in what kind of assessment measure or protocol needs to be undertaken, and the identification of the scale and scope of the project's initial design and its potential impact on the receiving environment, taking into account how will be affected by the changing climate, and engagement with key stakeholders to identify the policy and regulatory regime regarding the climate change in the project area. Then issues which we need to consider in scoping for adaptation include the regulatory and legislative requirements, whether they are applicable or not, the nature of the project, its location and resilience to climate change, the duration of the project, climate-related parameters which are likely to influence the project, anticipated changes to those climatic parameters over the life of the project, and the sensitivity of the environment potentially affected by the project in those climate parameters. Then we also looked up at consideration for baseline studies for climate change adaptation. So for determining the baseline studies, we look up at historic or past climate conditions which the area has faced, the current conditions at the time of the assessment, and the future climate conditions in the medium, that is 50 to 30 years, and in the longer term, which is 50 years or more, or at least the lifetime of the project. So you need to consider all these three weather related or climate related conditions for doing the climate change assessment. Also, the analysis of climatic factors that can affect adaptation can be done in three ways. So extremes in short-term weather events. So a short-term weather event could be like your a heat wave or a cold wave. So that's a short-term extreme event. Whereas extremes in long-term climate variability can be a larger changing of temperature ranges and changes in the average climate norms. Then vulnerability and sensitivity of receptors, that kind of classification can also be done, whether the receptors or the people who are facing this climate change effects are mostly dependent on these climatic factors. So then they are highly vulnerable or they have a high vulnerability. If they're moderately dependent on it, then they are they are facing they are under moderate vulnerability, and if the climatic factors have little influence on receptors, then it's a low vulnerability classification. Okay. Then we also looked at the impact of projects for climate change mitigation. So this can be done for projects which generate energy by using fossil fuel, which consumes energy and generates energy by using renewables, remove carbon or carbon capture and storage projects, or protect the carbon sink. So basically, we want to mitigate the climate change effects. So we want to focus on more renewable energy usage and development of more carbon capture and storage projects, and protecting carbon sinks which are already there. Then also sector-wise assessment also needs to be done for climate change impacts, because certain sectors are huge emitters of greenhouse gas emissions based on the type of activity or the um, 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 type of tasks that undergo in each of these sectors. So sector wise assessment also needs to be done. So different sectors could be agriculture and forestry, business, health and well-being, buildings, infrastructure, natural environment. So sector wise assessment also needs to be done for assessing the climate change impacts. So, for example, the risks and opportunities of climate change for built environment and health and well-being sectors. So, for built environment and energy, the risks are energy infrastructure at a significant risk of flooding. So, because of climate change, the energy infrastructure development which has happened, they are at a higher risk of flooding. There's a higher energy demand for cooling because of the higher extremes which are happening in the temperature, which has uh, you are facing more harsher summers. So you need higher energy demand for cooling. So the opportunity here is to reduce the energy demand for heating because the if the summers are hot, then the winters are also getting hotter because of the overall temperature rise because of climate change. So the opportunity here is that heating energy requirements are being reduced, whereas your cooling requirements are becoming a risk. So you have higher cooling requirements. Similarly, for your transport sector, you have roads, railways, and tunnels at significant risks of flooding. But the opportunity here is that shorter shipping routes and reduced transportation costs due to less Arctic ice. So because the ice is melting, that shipping routes and transportation costs are getting reduced in that transport sector. So that is an opportunity. So similarly, different sectors have different risks and opportunities which you can look up. So buildings also have similar things, and the built environment, health and well-being. So you can go through the lecture unit for these figures and for these analysis. Then we also have the vulnerability assessment approach, where we assess the magnitudes of the impact of the project on baseline conditions under the current conditions and the significance of effects. That is, conduct the EIA as normal without climate change. Then we identify the effect of climate change on the receptors without the project. And then we assess the impact of project, which impact of project, whether it will be worse or improved on the future baseline, and define if these changes affect the significance of the effects identified for the project without climate change. So something like this, where you have mitigation and adaptation consistency assessment. So this was proposed by Wilson and Piper in 2010. So you have different mitigation. You make a matrix out of the mitigation actions which you are proposing and the adaptation actions which you are proposing, and whether you see whether all of these actions are either supporting the other action or not, or whether they are totally inconsistent uh, with the other actions, because there are different. They might the mitigation efforts might deal with different environmental parameters, so they might not let's say uh, interact with each other in the favorable way, and they might be inconsistent in that uh, with each other. So you assess this to see whether whether what mitigation efforts you are proposing are working well together or not with the other mitigation measures which you are proposing. Okay, then the next lecture was lecture 37, which was on EIA methods for ecology. So here we looked up at the definitions and concepts first. So ecology, the study of ecosystems, habitats, communities, and species. Ecosystem is a self-sustaining functional system consisting of physical, chemical, and biological attributes. Habitat are conditions which are needed to support a species or community of species in a particular location. The community of species in a habitat is the grouping of different species that have evolved in ways that facilitate their coexistence and regularly and recognizably occur together. Then the biotype is the environment typically supporting such a specific recognizable community, and they can also be defined as biotope. So biotype or biotope. Then ecological impact assessment is the process of identifying, quantifying, and evaluating the potential impacts of defined actions on ecosystems or their components, and provides a scientifically defensible approach to ecosystem management. Then we looked up at certain ecological receptors. So we have ecosystems, the species population, that is the number of species which are present. The individual species, ecological features, unique landscapes, and areas of habitat essential to the structure and function of ecosystem as associated with the proposed development. So these are the ecological receptors when we talk about ecological receptors further down this lecture. So then we also looked up at the key factor of ecosystem. So there are many interactions that take place between the components and process. So if you remember, you have a food cycle that you would have studied in your biology lessons, and you would have uh, a food chain. So you realize that all of these different components are dependent. The population of the species, how they are spread out, and that intricate balance is maintained because of the different linkages and interactions which different components and processes have. So, for example, your vegetation cover is dependent on the soil, which is dependent on the bacteria and fungi um, as well. So, these kind of interactions are there. So, this is the key balance which we talk about for ecosystems. Then we measure ecosystem resilience in terms of stability, fragility, or sensitivity, the resilience or recoverability, and recreatability. So, stability is the state in which changes over time are within the normal bounds of variations. And this is the ability of an ecosystem to resist environmental change as well. Then we have negative feedbacks, which are feedbacks within the ecosystem that slow down the process. So, this is because of the interactions of the ecosystem, which are basically saying that this is not working out. So they give negative feedback. That is, they slow down that process, and that process eventually gets phased out. Then inertia is the delay or time lag or slowness in the response of an ecosystem to a driver of change and in its recovery if the cause is removed. Fragility or sensitivity, another ecological ecosystem resilience parameter, is the ecosystem susceptibility or weakness to environmental pressures. So a fragile ecosystem is more easily altered and may lose its abilities to recover from impacts more easily than a stable ecosystem. The resilience is the ability of an ecosystem to absorb disturbance without crossing a threshold to a different, usually degraded state, in which case it is virtually synonymous with stability. Recoverability is the ecosystem's ability to return to a pre-disturbed state and the speed at which it can do so if once the disturbance is removed. And this is an important aspect for EIA in the short term, in assessing the short term impacts, such as during the construction phase, because you have a lot of construction, new materials which are introduced in the ecosystem, and they are just there during that construction stage because they might. The cement might get mixed with the soil for in the shorter term because you are mixing it together or something. So these they might lead to short term impacts, recoverability, but the ecosystem will recover because after the construction stage. So at what rate will it recover? That is a key point. And this is something which is used in the IA short-term assessment relating to ecosystem assessment. Then recreatability is the potential for the establishing an ecosystem of richness and complexity, similar to the ecosystem that has been destroyed. Habitats are based on the species composition, that is the number and different types of species in the landscape. So it gives a quantitative idea on the species abundance and the description of the dominant species, the keystone species, and indicator species. Then we also looked up at vegetation structure or physiognomy, which is the physical structures and features of vegetations, which influence the behavior of wildlife populations, such as life form compositions and the vertical structure. Then we looked up at species richness, uh, the measure of biodiversity, trophic structure, flow of energy and nutrients to communities and ecosystem, the food chain and food webs, the spatial pattern, which is the spatial configuration of communities, that is your plant, animals, and microbes. We also looked up at transition zones or ecozones. So these are zones between adjacent communities, and they are often species rich because they contain species of adjacent communities. We also looked up at temporal pattern, which is community change through time. So short-term temporal changes are seasonal variations, which are the intrinsic vegetation cycles. So they are associated with forest canopy gaps, or they can also be these changes can also cause environmental perturbations, because of environmental perturbations like fire, storm, flood, drought, and cold. So those are temporal changes. So you see seasonal variations like when the trees lose their leaves, and environmental perturbations like a firestorm. It causes the community to change because of an outside event which is happening. So those are temporal changes. Then ecological succession is progressive process that culminates in the development of a climatic climax, community meaning a steady state. Then we looked up at species population. So species composition is described in numbers and the type of species that are present in a particular area. Now, three key terms are used for looking up at species population. So we have species abundance, species richness, and species diversity. Uh, then we also looked up at pollution indicator species. So different kind of lichens and fungus. They are indicators of the environmental pollutants which are present in the air. So presence of, for example, lichens are indicators of sulfur dioxide in the air. Black spot fungus is also an indicator of sulfur dioxide in the air. And other similar kind of species. So these are pollution indicator species. Then we looked up at approach for baseline study. So we have listing approach, snapshot approach, and dynamic approach, which you can refer back to the lecture to study in depth. So for undertaking the baseline study, first we need to identify the species which can tolerate short-term environmental variations. And species often return to prior stable conditions or settle in a new equilibrium supported by the altered environment. So first you identify species which respond to environmental changes by evolving or changing their geographical ranges. Then you identify specialists which are adapted to a narrow range of environmental conditions or food sources and are more vulnerable to environmental changes. Then you identify generalist species. So these have less specific foraging requirements. So these are general species which are available all in all kinds of environment, where specialists agree like exist in species exist in areas where their food requirements are being met, or soil is of a particular has particular characteristics like pH or nutrient ratios. So those are specialist and generalist species. You identify the different kind of species first. Then continuing Continuing lecture 38 for AIA methods for ecology, which is on baseline studies. So now we look up at the scoping stage. So first you determine the study area, that is your impact area or the project affected area. So how much area the project, apart from the proposed site, how much area it's going to affect. So that study area you need to identify as your impact area. Then you need to determine your survey methodologies which you're going to use in doing the scoping, then the assessment methodologies and their level of significance, and the key ecological issues to address, their inclusion and exclusion list. Then we also have something known as a valued ecosystem components or VEC. So these are species, habitats, or site that qualify in terms of their ecological or conservation values or other attributes such as socioeconomic value. So those are VECs. Then in the scoping stage, you finalize the methods for survey for each habitat and species under investigation. You finalize on your sampling methods and the sampling parameters, I would say rather, which is your number of samples you're going to collect, the timing of each samples, how frequently you're going to collect them, and the location of each survey to be undertaken. Then you finalize your methods based on the ecological importance, the impact magnitude, and impact significance, and how you're going to report them. Those reporting requirements are also finalized at scoping stage. So, description of environment is in terms of whether the project size falls under the sensitive, environmental sensitive areas like your national parks, your wildlife sanctuary, game reserves, tiger reserve, elephant reserve, turtle nestling grounds, mangrove area, wetlands, reserved and protected areas, etc. So if it falls under an ecological sensitive area, then certain other they need to be dealt with more in more detail and more depth and sensitively. So then the entire EIA method and focus shifts. But if your location does not fall under your environmental sensitive areas, then you can do a normal environmental baseline study. Okay. So, in terms of data which we collect during baseline studies, so but in terms of biological data, we identified how many species of plants and animals are there, that is flora and fauna, the type, density, and exploitation of flora, the distribution, abundance, rarity, if there are migratory species, the species diversity, habitat requirements, habitat resilience, economic significance, and commercial value. You determine those for your fauna or animal species that you have. For fisheries, again, you identify migratory species, species with commercial or recreational value. Then you also have certain organizations which have ecological data, which they collect. So you can get these organizations to give you data if they are available for your development site. So your state agriculture departments, your World Wildlife Fund, the Wildlife Institute of India, Survey of India, Botanical Survey of India, these kind of organizations, they hold data for these kind of, uh, so you can directly take them for your desk studies and surveys. For your field surveys, you need to first look up at the variations which are available, which occur due to seasonal climate and migratory species if they are coming in, what is that time frame. Then you also need to start at least 1 year before the submission of the environmental impact assessment report, because you need to give them a 1 year analysis on how the species migrate and which species come in and what year and so on. So for fieldwork, you need to do that. For desk studies, you need to see whether there's availability of data from these organizations, which we saw in the last slide, and whether a detailed survey of the area is available. If you can use GIS mapping for getting those kind of data. What kind of human resource you have, what kind of ecological expertise or expert panel you have, and whether you require professionals or not to do the desk studies. Okay. So simple techniques which can be used for your baseline studies and your field work. So these are ecologists field walking, that they can walk in your development site and see what species are there and make a note of it. Visual assessment based on photographs and people on site. Recording and thematic mapping or classification system. Then methods for spatial mapping of vegetational habitat. So these can include handheld electronic devices on GPS. You can also use satellite imagery, aerial photography, GIS, line intercept method. So line intercept method is when parallel lines are drawn on a map or aerial photographs, and it's used to estimate the spatial distance occupied by each habitat type along a line, and it gives the measure of proportion or the percentage of site which is covered by each habitat type. So we will look up at an example with the image for line intercept method. Then other techniques which I use for wildlife assessment are observation or presence of tracks, whether you have certain paw marks or something. So you identify whether different species are on coming to site or not, whether there are signs of feeding, that is, you find bones or carcasses on your site, so it indicates that a carnivorous being is present on your site or has a movement pattern through your site. So you need to address that as well. Whether there are resting or occupation areas, if you have a water body or a water area, whether different species are going to come and drink from that water body, uh, natural water body, before any intervention has happened. Whether there are tunnels, whether there are hairs and feathers of different species which can be found on the site, scratches, marks on vegetation and in the soil, scat, dung, or feces. So if you find any of these are also indicators of the presence of wildlife and different species. So field experts can then do an analysis on what species and what uh, how many they can predict. So for species abundance methods, we have four methods. So we have the semi-quantitative abundance ratings, the number of individuals covered usually expressed as a percentage, and frequency also expressed as a percentage. So these methods are semi-quantitative abundance methods. So these are using systems like DAFOR. So D is for dominant, A abundant, F frequent, O occasional, and R rare. So based on different species which are found on site, you can give them a rating, like this is most abundant on site, this is rarely sighted, this is occasionally seen, this is most frequently visiting, and things like that. So you give that abundance rating to each of these species. So this is like an initial assessment rather than detailed studies. So the second measure is the number of individuals. So in this, you can count the number of individuals. So you can express them as density or population size. So first is direct counting. You can directly count as one, two, three, four. If you can directly count like large trees, you can directly count large animals, you can directly count and things like that. Then indirect counting methods. So these are done for fairly smaller populations. And then capture, mark, recapture method. So this is a method in which you capture and mark the individuals of different species, and then you release them, and then you keep catching new ones, and then you see how many of them are recaptured, like how many of the members you have already marked and they are getting recaptured. So then you estimate how many are new and how many members might be there if you are getting already marked members after a certain point. So these are methods for number of individuals measured. Then cover is basically how much is uh, percentage of ground is occupied by the different species. So that is expressed as cover. And then again, under this, you can also have different methods. So you can go through them in detail in the lecture. Then frequency is the percentage of observations in the sample that contain the species as determined by their presence or absence. And again, this is done in quadrants. So you divide the site in four parts, each a quadrant, and you basically measure how much distribution is there, high density, low density, different species. And one negative associated with this is that it tends to overestimate or overrepresent smaller species. So again, you can read about them more in detail, but these are the four methods for measuring the species on the site. Then, for preparing detailed ecological surveys, you need to supplement the findings of your primary survey and desk studies, which often lack quantitative data, and to collect enough quantitative information to create a baseline information. So, for data collection methods, you have plot sampling, which is what we looked at, that is dividing the site into quadrants and then sampling each of the quadrants separately. Then you have plotless sampling, which is like transit walking or using the line intersect method, or distance measurements from different sampling points. Again, they are being covered much in detail in the lecture, so you can refer to the lecture for this. This is just like a revision to what we looked up. And specialized collecting equipment. Then survey methodology specification at planning stage. It looks up at temporal sampling patterns, the sample size, and the percentage of area target. So plant surveys, for example, can be done in these when quadrants are specified. So you have specific quadrants and you see how much area is being studied, and then the what quadrant, what species are found. So a single quadrant can be there, or you can have something like a belt quadrant as well. Then you can have look up at transects also at some point. Then we have for animal surveys, we have active and passive surveys. So for fishes, active survey techniques include electrofishing from backpack, boat, or bankside, netting using seine nets or scoop or dip nets, fish traps or fish passes, enclosure traps, angling, visual sensors using diving boats or remote control underwater vehicles. Whereas your passive techniques include gill nets or pike nets. So you count the number of fish species you can find based on these techniques. Then for amphibians, you survey at the breeding sites, that is ponds, swamps, or slow flowing rivers, or around the site during the breeding season. Main methods are pond netting for individuals in the water, torching at night to count the number of species, the bottle trapping, searches for frog and toad egg masses during the breeding season, So these kind of methods are we looked up at amphibian surveys. Then for reptiles, methods of trappings like pitfall traps for smaller species, transit walking, or areas of artificial refuges. For larger species, you have direct observation or capture, mark, and release techniques. Then for birds, you record the presence of species and where possible estimate the size of populations and their vulnerability to potential impacts. You also look up at breeding surveys and transient surveys, transit walking, and other techniques like flight line surveys, radio tracking, and collision mortality monitoring. So those are for birds. Then for mammals, we have three groups of mammals. So we have bats, small mammals, and larger mammals. So for bats, we have direct observation or ultrasonic detectors, endoscopes or photographic cameras, light pathways, detection by staining, droopings, or insect remains. Then we also have indirect methods, tracks, nest tubes, live tracking, mark recapture using traps, snap traps, and optical and infrared photography using sensor activated equipment in these bat cave kind of places. Then for larger mammals, you have direct observations using field science and survey methods, and you can also use radio tracking. Then for sampling terrestrial invertebrates, we have observer-dependent methods where you need a observer to count or to look at. So you have direct searching, recording, transit walking, sweep netting, swish netting, suction sampling, soil samples, beating, subsidiary methods. And observer-independent methods are pitfall traps, melee traps, sticky traps, water traps, light traps, and emergence traps. Again, whatever is discussed in the lectures will what will come in the examination. Nothing extra or more in depth will, like, you can read about them for your own understanding, but whatever has been discussed in the lectures, only that much will come in your examination questions. Okay. Then we also looked up at three kind of habitat. So first is modified habitat. So habitat which supports a community which contains a large proportion of non-native or introduced fauna and flora, or where human activities have modified the area's primary ecological functions. So those are known as a modified habitat, which has been affected because of the invasion of non-native species. That is, you find more non-native species in that habitat compared to the naturally occurring species in that area, or whether some man-made activity has introduced a new fauna or flora to that site for, let's say, landscaping purposes or something. So that is a modified habitat where you don't see the primary ecological functions because it has been modified for certain reasons. So examples of these are like agriculture, parks, commercial forestry and plantations, or the claimed or modified wetlands and rivers. So those are modified habitat. The natural habitat are areas which are composed of viable assemblages of plants and animals, species of largely native origin, and or where human activity has not essentially modified an area's primary ecological functions and species composition. The third kind of habitat is the critical habitat. So this is a key habitat in maintaining the global biodiversity. So these include sites which contain high biodiversity values. So for example, sites which have habitat for critically endangered or endangered species, for endemic or restricted range species, and or significant concentrations of migratory or congregatory species for parts of the year. So habitats which basically support endangered or critically endangered species, and that contain unique or highly threatened ecosystem and areas associated with key evolutionary processes. So those are critical habitats which have been identified as critical for the survival of certain species. These are the three kind of habitats. Then we also looked up at the environmental variables and site history and changes without the development. So relevant data which you need to collect while doing an AI is again on topography and aspect of the site, the local climate information, soil conditions, water quality, river geomorphology, pollution levels, existing and historic land, habitat and site management. And you need to document past conditions, historical and archaeological information, and evidence on ecological conditions using the paleoecological techniques. Now, these some of these data can be obtained from different organizations if they have it for your particular sites. Then changes without development include valid assessments about the ecological impacts of a project. Consider what changes in biodiversity may occur in its absence. Description should include, for example, so when you submit the ecology report, you need to give a brief description on the aims and scopes of the investigations, the description of the ecological surveys undertaken, the detailed field surveys which were undertaken, weather conditions, findings of the initial survey, the provenance and age of the data collected, clear presentation of the results of the work, the evaluation of all key receptors, the assessment of the environmental factors, and information on current land use and indications of limitations. Then we move on to lecture 39, where we looked up at EIA methods for ecology, the impact prediction and evaluation. So, in terms of identifying the impacts on ecology, the International Finance Corporation IFC's Performance Standard 6 gives the states that the assessment should include direct impacts, indirect impacts, residual impacts, and cumulative impacts. All these four kind of impacts. So direct impacts are like your habitat loss, disturbance, emissions to air, land, and water, alterations of surface hydrology and landforms, edge effects, forest gaps, loss of provisioning ecosystem services, degradation of regulating cultural and supporting ecosystem services. So these are your direct impacts. Indirect impacts include accidental introduction and spread of invasive species or non-native species, project-induced access by third parties, in migration and associated impacts on resource use. So those are indirect impacts. Now, the ecological impacts can be measured in three types. So you have pulse, which is temporary, press, which is sustained, and catastrophic, which is highly destructive of it or irreversible. So these are your indirect impacts. And then okay. We also looked up at the significance of the habitat destruction. So the ecological conservation value and species dependency will get affected if habitat is destructed. The presence of rare, protected, or notable species within the habitat is lost. The degree of displaced species might migrate and survive in suitable sites or habitat patches, but the quantity of the habitat is lost, and how much fragmentation will occur and integrity of the habitat will be restrained. Um, so you need to look up at the significance of the habitat destruction, because any sort of construction activity, any sort of proposal is going to lead to a habitat destruction or habitat modification only. So you need to address the habitat destruction and the different aspects coming out of it in detail and give mitigation measures for it as well. So and then we also looked up at the obstructions or blockage created between the habitats. So physical includes like preventing wildlife from crossing a site. So, for example, if you have roads which connect different states, they might run through a wildlife area. So that construction of the road is going to divide the habitat into two parts. So this is a physical obstruction or blockade. And you would have heard a lot of news articles, especially in the past years. You would have heard now they are more safe and secure, but you would have heard of animals being killed because of traffic movement in these kind of areas which are known for having wildlife. Then another kind of obstruction is behavioral, like creating an environmental condition that wildlife is unwilling to enter. So when you have electric nets which prevent their movement, so that is a behavioral blockage. And these barriers can also be hazardous to both how the uh, wildlife behave, as well as how they start perceiving and what happens like that. So we also have something like the edge effect. So you see in a habitat, usually there's also always going to be an edge. So this edge is there because the pattern, the habitat changes. So they give like a buffer area, basically. So as you see the habitat size reducing, you see that the percentage of the edge effect increases, because the edge is going to be the same, but the habitat size, that is this green area in which you find mostly the species which are present, that area gets reduced. So when we do like development and when we keep on reducing the habitats, this leads to edge effects and loss of species and habitats. Then the effects of habitat isolation. So the species dispersal, habitat isolation leads to species dispersal capabilities, affects the species dispersal capabilities. The nature of the land use between the habitat patches is affected. The degree of isolation between habitat patches increases, and the distances and severity of the barriers between them are also affected. So you need to address these in your EIA reports as well. Then this is what we talked about habitat fragmentation. So when we have a habitat, and for example, we have city A here and city B this side. So we need to, for connecting the two cities, we will go with the least uh, path of least distance. So when we connect city A to city B, we basically fragment the habitat two into two parts, and we restrict the movement of these species. So this is habitat fragmentation, and you see the edge effects and how the habitat area is being reduced uh, because of one human development, that is one road development. Okay, so these kind of aspects come into your ecological impact assessment section of your EIA report. Then we also looked about significance of barriers, which varies between the species. So some species have efficient dispersal mechanisms that are not seriously affected by most local barriers. And some species have very limited dispersal ability, and such low mobility species are restricted to remaining in their habitat patches, and they're unlikely to decolonize isolated habitat patches. So some species are mostly affected by these kind of habitat fragmentation. So you need to identify those species and how you're going to address this habitat isolation which is happening because of your developments. Okay. Then also identifying the causes of habitat damage in because of your project. So where vegetation trampling is happening, with whether plant damage or removal is happening because of your project, any sort of activity in your project. Proposed project. So plant damage or removal and soil compaction or erosion, where the topsoil is being removed and uh, replaced. Um, and it occurs mainly during the construction phase of the projects, and traffic and recreation or visitor pressure and increased hunting pressure and destruction of microhabitats. Then also identifying causes of wildlife disturbances if your wildlife is affected, if your project size is in an ecologically sensitive area. You need to identify wildlife disturbance patterns and their magnitude as well, and for the different species which you would have identified in your initial surveys. Then also the impact of changes in the hydrological systems and climate, whether there are soil droughts, loss of wetland inhabitants, the increase in water level, damage to temporary water habitats, and things like that, changes in the properties of the water which is found. This is so now we look up at a few of the methods. So we looked up at the transect and line intercept method. So this is for determining the coverage and relative dominance. So what we do is we draw a line and we know the length of the line. So whatever species of plant uh, is found on this line, we consider uh, the length of that plant. So for example, now we will look up at the cover glass. So you see this cover glass has a width of 1, like it occupies 1 unit in this 10-part line. Then another 1.7 unit in here, and then another zero point 0.6 and another zero point 0.8 on this line. So you add the total percentage of grass cover, which is 1.7, zero point 0.6, and zero point 0.8, divided by the total length of this line. So you get 41% of this line has the coverage of grass. So by this analysis, you identify the cover and relative dominance of a species. So this is the first method where we use lines to identify the ratio between the different species which are found on the site. So this is the method which we use for flora. Then we also have plotless sampling methods. So we divide the plot and then we measure the distances and mean point plant value and the mean area per plant density and relative density, dominance and relative dominance, and importance values. So different methods are there. You can read about them in the lecture. This is just for your revision that we looked up at these methods as well. Then we also have a species list method. So we have animal species which are listed and the different animal communities which can be observed directly. So you can directly look and identify that these kind of species are occurring on site. Then count in this method. So you have drive count. So you make the cattle or the animals run past a particular point, and then you directly count the number of individuals which are running past that point. Then you also have market capture methods. So again, you count, you capture first certain animals, you mark them, and then you release them, and then you again capture. So that's how you calculate. You do these market capture methods. Then we also have certain mathematical and statistical models which we looked up at, which was minimal critical areas, viable populations, ecotoxicology, critical loads, and hydrological processes. And so for testing the significance of impacts which on ecology specifically for the Indian sectorial manuals. So this kind of analysis you can do, that is, will there be, you have a set of questions and then you have a yes and no in terms of whether they are directly affected and the nature and effects and the reasons. So, for example, you can do questions like, will there be a large change in environmental conditions because of your proposed development? So you say yes, and then you list the effects and the reasons for that. Then you can look up at how many people will be affected. Will many receptors of other type, that is fauna and flora, business facilities, etc., will be affected? So yes, and then you list all of these effects. So that is how you put them in the EIA report. And similarly, what is the risks associated to the protected sites, areas or features which will be affected, whether the effect will be permanent or temporary, whether it will be continuous rather than intermittent, will it be difficult to avoid or reduce or repair or compensate for the effect? So these kind of questions help you guide towards your impact assessments and evaluations. So then we also looked up at receptor sensitivity, which is the function of the ability of a species or habitat to accept change in the environment and its resilience to any changes which may occur further. Last lecture for week 8, we looked up at EIA methods for ecosystem services. So we have already earlier looked up at the different kind of ecosystem services, the kind of services that the ecosystem provides, like your provisioning services, regulatory services, supporting services, and cultural services. Um, and now here we looked up at certain new definitions. So we had the natural capital, which was the stock of living and non-living environmental resources potentially available to generate value. Then we looked up at financial services, which are direct benefits to well-being, like livestock farming, and they are easy to identify. Then intermediate services are the indirect support. So they contribute indirectly to our well-being by supporting other services. So, for example, hay production for supporting livestock production, and they are difficult to identify. We also looked up at the evaluation of ecosystem services. So we looked up at the preference evaluation methods, the payment for ecosystem services or PES, fees for user, which is biodiversity conservation in the United States, Costa Rica, and Nicaragua, and watershed protection in South Africa and Mexico. And the polluter pays kind of thing, like for carbon sequestration, which is seen in China and UK, where the polluter pays a certain penalty or compensation. Then we also looked up at ecosystem service demand and use. So, ecosystem service demand, like the level or amount of ecosystem services which are desired by the beneficiaries to fulfill their requirement. And if the demand is realized or met, it equates to use, like demand is equal to use. ecosystem service use is the level of a particular ecosystem service actually consumed or enjoyed by the beneficiaries. And the use can be consumative or non-consumative type. So for the ecosystem services also we have a demand and use kind of curve, because we are associating the services to a monetary kind of angle. So we look up at the demand and use curve, which we see uh, in economics specifically as well. So usage again is the area people use for getting a particular ecosystem service. Another definition: the ecosystem service supply is the maximum amount of service that can be drawn from an ecosystem without damaging its future productive capacity. And this is also called as maximum sustainable yield. Then we looked up at uh, supply characteristics like supply type, which determines which services are provided. The conditional health, which determines the capacity of the ecosystem to supply them. And this is affected by the way the sources are managed outside, of course. Then we also looked up at the consideration of geographical extent of an ecosystem for the assessment of the capacity of ecosystem to supply services. So in terms of geographical extent of an ecosystem, the biodiversity, structure, processes, accessible supply, and impermeable barrier to use the supply. So this was all which we looked up at in this in the entire week's content. So this was the revision. So if you have any questions, you can either put them in the chat box or you can just unmute and ask yourself. Okay, so if there are not any questions, we will now go on to the Q&A sections. So for answering these questions, you can put the answers in the chat box and I will moderate this Q&A. So these are all questions which are based on this week's content. Okay, so first question is, what is the acronym of NDC in relation to climate change policy frameworks? Is it A, national development contributions, B, naturally determined contributions, C, nationally determined contributions, or D, nationally democratic contributions? So the full form of the term NDC in relation to climate change policy framework. Here we have one answer. Okay, so the correct answer is C, that is NDC stands for nationally determined contributions. So these are contributions to reduce the greenhouse gas emissions, national greenhouse gas emissions from all of these different nations, and to reduce the impacts of climate change. So each nations have different nationally determined contributions. So for example, the US said that it will reduce 50% of its carbon emissions by a particular year. So that is a nationally determined contribution. So C is the correct answer. Moving on to the next question, state true or false. Scoping in and scoping out with respect to climate change in AIA process mostly depends nation to nation based on their legislative provision. Is this statement true or false? Okay, so this statement is true. That is, different nations have different scoping methods for EIA, specifically relating to climate change, because of again their determined NDCs and things. So the legislative provisions and the legislative mandates which the scoping procedure should meet are different. So the given statement is true. Moving on to the next question. So select the following issues to consider in scoping for climate change adaptation. A, nature of project, its location and resilience to climate change. B, climate related parameters likely to influence the project. C, anticipated changes to those climatic parameters over the life of the project. Or D, all of the above. So, Okay, so the correct answer is D. That is all of the above. So all of these are the issues which we consider in scoping for climate change adaptation. Along with this, we also look up at the applicable regulatory and legislative requirements, again different for different countries, the duration of the project, and climate related parameters which are likely to influence the project, and changes to those climatic parameters over the life of the project, and sensitivity to environment potentially affected by the project to those climate parameters. Okay, so D, all of the above is the correct answer. So moving on to the next question. Which of the following information are considered for baseline studies for climate change adaptation? A. Historic or past climate conditions. B. Current conditions at the time of the assessment. C. Future climate conditions, medium and long term. Or D. All of the above. So we have one answer. Okay, so D, all of the above is the correct answer. So for considering considerations for baseline studies for climate change adaptation, requires information on historic and past climate conditions, requires information on current conditions at the time of assessment, and requires information on the future climate conditions for the medium and longer term, that is 15 to 30 years or more than 50 years or the lifetime of the project. So all A to C are the correct answers. So D is the correct answer. Moving on to the next question. So match the following terms of group A with their description in group B. So we have terms in group A and their definitions in group B. So you need to match group A with group B. Okay, so the correct answer is B. That is ecology is the study of ecosystems, habitats, communities, and species. So P matches with 3. Ecosystem is self-sustaining functional systems consisting of physical, chemical, and biological attributes. So Q matches with 1. The habitat is are conditions needed to support a species or community of species in a particular location. So R matches with 4. And biotype is environment typically supporting a specific recognizable community. So S matches with 2. So the correct answer is B. That is P matches with 3, Q matches with 1, R matches with 4, and S matches with 2. Okay, moving on to the next question. So match the ecosystem resilience attributes given in group A with their elaboration given in group B. So we have terms like stability, fragility or sensitivity, resilience or recoverability, and recreatability. Okay, so the correct answer is C. That is, stability is the state in which changes over time are within normal bounds of variation. And this is the ability of an ecosystem to resist environmental change. So P matches with 2. Q, fragility or sensitivity is the ecosystem susceptibility or weakness to environmental pressures. So Q matches with 4. Then resilience or recoverability is the ability of an ecosystem to absorb disturbance without crossing a threshold to a different, usually degraded state. So R matches with 1. And recreatability is the potential for re-establishing an ecosystem of richness and complexity, similar to the ecosystem that has been destroyed. So S matches with 3. So the correct answer is C, that is P matches with 2, Q matches with 4, R matches with 1, and S matches with 3. Okay, moving on to the next question. So, what do you determine in the scoping stage for EIA method of ecology? A, study area. B, survey methodologies and assessment methodology. C, key ecological issues to address. Or D, all of the above. So, which of these do you determine in the scoping stage for EIA when you finalize the method for doing ecological impact assessment? So we have one answer D. So D is the correct answer. So during the scoping stage, we determine the study area. So A is correct. We determine the survey methodologies and assessment methodologies and their level of significance. So B is also correct. And then the key ecological issues to address. that is making the inclusion and exclusion list. So C is also correct. So all of the above, D is the correct answer to this question. Okay, so moving on to the next question. So which of the following are the simple techniques used for ecological survey? A, ecologist field walking and visual assessment. B, recording. C, thematic mapping. Or D, all of the above. So we have one answer D again. So D is the correct answer. So simple techniques which are used for ecological survey are ecologist field walking and visual assessment. Second is recording. Third is thematic mapping using a classification system. So D, all of the above is the correct answer. Moving on to the next question. Habitats will support a community which contains a large proportion of non-native or introduced fauna and flora, or where human activities have modified the area's primary ecological functions is called A, natural habitat, B, modified habitat, C, critical habitat, or D, none of the above. We have one answer, C. Okay, so the correct answer is B, that is modified habitat. So modified habitat supports a community which contains a large proportion of non-native or introduced fauna and flora, or where human activities have modified the area's primary ecological functions. So these include areas like agriculture, parks and amenity areas, commercial forestry and plantations, and reclaimed or modified wetlands and rivers. Whereas natural habitat is habitat which is naturally occurring and where no human activity has caused an introduction of a non-native species. So that's the natural habitat. Whereas critical habitats are habitats which are critical for the I'm sorry, which are critical for the certain species, critically endangered or endangered species to survive, or areas which have certain ecological value. So those are your critical habitats. So the answer B, that is modified habitat, is the correct answer. Okay, moving on to the next question. So identify the method as shown in the image, which is used for impact modeling of flora. Is it A, sample plot methods, B, transects and line intercepts methods, C, plotless sampling methods, or D, species list methods? So, okay, so we have an answer B. So B is the correct answer. So this is the transects and line intercept method. So the line is of a length of 10, and then we mark the percentage of cover that different species have on this line. So this is the transect and line intercept method. So B is the correct answer. Moving on to the next question. So match the following methods for impact modeling of biological environment given in group A with the application given in group B. So in group A, we have different methods, and in group B, we have the uh, um, basic description or application of those methods. Okay, so the correct answer is D. So the species list method is the list of animal communities which are observed directly. So P matches with 4. Count index methods, roadside and aerial count methods. These are the observations of animals by driving them past trained observers. So this is Q matches with 3. Then removal methods are matches with the number of species captured. So R matches with 1. And plotless sampling methods S matches with mean point plant distance and mean area per plant. So S matches with 2. So the correct answer is D. That is P matches with 4, Q matches with 3, R matches with 1, and S matches with 2. Okay, so moving on to the next question. So state true or false. Market capture methods is one of the methods for impact modeling of fauna. It involves capturing a portion of the population and at some later date sampling the ratio of marked to total animals caught in the population. Is the statement A true or B false? Okay, we have two answers A. So A is the correct answer. That is in the market capture method. We capture it's for impact modeling of fauna. So we capture a proportion of the population, animal population, and at some later date and sampling, we do the ratio of the marked animals to the total animals which were caught. So the statement is true. That is A is the correct answer. Moving on to the next question. Match the following terms of ecosystem services in Group A with their description given in Group B. So we have different terms from the ecosystem services module and their description in Group B. Yeah, so I have another answer B. So the correct answer is B. So natural capital is the stock of living and non-living environmental resources potentially available to generate value. So P matches with 3. Then final services are direct benefit to human well-being. So Q matches with 1. Then intermediate services are, contribute indirectly to human well-being by supporting other services. So R matches with 4. And beneficiaries are people who derive benefit from an ecosystem service. So S matches with 2. So the correct answer is B. That is P matches with 3, Q matches with 1, R matches with 4, and S matches with 2. Okay, so moving on to the next question. So match the following terms of ecosystem services in Group A with their description given in Group B. So again, definitions and their descriptions. Okay, we have one answer. Okay, so the correct answer is A. That is, use shed is the area people use for getting a particular ecosystem service. So P matches with 2. Then ecosystem service demand is the level or amount of ecosystem service desired by beneficiaries to fulfill their requirement. So Q matches with 3. Ecosystem service use R matches with 4. That is the level of a particular ecosystem service actually consumed or enjoyed by beneficiaries. And the use can be consummative or non-consummative type. And S ecosystem service supply is the maximum amount of service that can be drawn from an ecosystem without damaging its future productive capacity. So the correct answer is A. That is P matches with 2, Q matches with 3, R matches with 4, and S matches with 1. Okay, so moving on to the next question. Select the Congregation of Parties or COP meeting by which India aims to reduce the carbon intensity of its economy by less than 45% until 2030. Is it COP23, COP24, COP25, or COP26? So we have two answers. Okay. So the correct answer is D. That is in the Congregation of Parties 26. India made this commitment that it will reduce the carbon intensity of its economy by less than 45% until 2030, and that by the year 2070, India will achieve the target of net zero. So the correct answer is the COP26 or Congregation of Parties 26 is the correct answer. So D is the correct answer. Moving on to the next question. What is the full form of UNFCCC? Is it A, United Nations Framework Convention on Climate Change, B, United Nations Framework Conference on Climate Change, C, United Nations Framework Classification on Climate Change, or D, United Nations Framework Committee on Climate Change? Okay, so we have one answer A. So A is the correct answer. That is UNFCCC stands for United Nations Framework Convention on Climate Change. So A is the correct answer. Moving on to the next question. Match the terms given in Group A with their description in Group B according to the vulnerability and sensitivity of the sector's classification. So in Group A, we have the different vulnerabilities and sensitivity of the sectors, that classification. And in Group B, we have their description. The B. Okay, so the correct answer is B, that is high vulnerabilities when the receptor is directly dependent on prevailing climatic factors and reliant on their continuation or limited variability, that it will be this receptor will be highly affected by any changes in the climate, so it is highly vulnerable. So P matches with 2. Then moderate vulnerability is when receptors dependent on some climatic factors but able to tolerate a range of conditions. So that is moderate vulnerability. So Q matches with 3. And then low vulnerability is when climatic factors have little influence on receptors. So R matches with 1. So the correct answer is B, that is P matches with 2, Q matches with 3, and R matches with 1. Okay, so moving on to the next question. So match the ecosystem resilience. I think we have covered this question previously. Uh, so moving on to the next question. So match the following terms of Group A with their description in Group B. So we have different terms in Group A, and in Group B we have their definitions. Okay, we have another answer. Okay, so the correct answer is C, that is, ecosystem is a self-sustaining functional system consisting of physical, chemical, and biological attributes. So P matches with 4. Then habitat are conditions that are needed to support a species or community of species in a particular location. So Q matches with 3. Then biotype is the environment typically supporting a specific recognizable community. So R matches with 1. And ecology is the study of ecosystems, habitats, communities, and species. So S matches with 2. So the correct answer is C, that is P matches with 4, Q matches with 3, R matches with 1, and S matches with 2. Okay, so moving on to the next question. State true or false. According to the IAIA, there are 4 key questions for scoping with respect to impact on climate and climate change. Is the statement true or false? Okay, so we have 1A. So the correct answer is A, that is according to the IAIA, that is International Association for Impact Assessment. We have the 4 questions for scoping, which is whether to and to what extent the proposal will directly or indirectly increase or decrease greenhouse gas emissions. The second question is whether or to what extent the proposal may be beneficially or adversely affected by and vulnerable to climate change, either directly or indirectly. The third question is whether and to what extent the climate change may affect other aspects of the environment that are potentially affected by the impacts of the proposal. And the fourth question is what is whether and to what extent the proposal will identify um, an objective of the proposal is to use impact assessment to identify alternatives and measures to mitigate and or to adapt to climate change. Okay, so these are the 4 questions according to the IAIA, so, which are used for scoping. So the statement is true, so A is the correct answer. Now moving on to the next question. So which among the below given is the approach for baseline study? A, listing approach, B, snapshot approach, C, dynamic baseline, and D, all of the above. So we have 2 answers D. So D is the correct answer. All 3, that is listing approach, snapshot approach, and dynamic baseline are approaches for baseline study. So D, all of the above is the correct answer. Moving on to the next question. So DAFOR is used for species abundant measures. So what does DAFOR stand for? Okay, so we have one answer A. So A is the correct answer. That is D stands for dominant, A is abundant, F is frequent, and O is occasional, and R is rare. So these are the indicators which we give to the different species for an initial assessment based on how abundant they are on site. So A is the correct answer. Moving on to the next question. So, what is plotless sampling? A, sampling is conducted within defined plots. B, sampling is not conducted within defined areas. C, sampling is conducted using quadrants. Or D, sampling is conducted using circles. So we have one answer C. Okay, we have an answer B. Okay, so the correct answer is B. That is, sampling is not conducted within defined areas, and it is rather conducted based on the point difference from a specific point. So you get the mean point distance and the mean area per plant. So as the name itself suggests, plotless sampling. So the sampling is not conducted within defined areas. So B is the correct answer. Okay, moving on to the next question. State true or false. Some species have very limited dispersal ability, and such low mobility species are unrestricted to remaining habitat patches and too unlikely to recolonize isolated habitat patches. So is the statement true or false? Okay, we have an answer A. Okay, we have another answer A. Okay, so the correct answer is B. That is, because of barriers which are created between the landscape, these limited dispersal, some species have limited dispersal ability. That is, they are not able to move to the remaining habitat patches because of these dispersions, and they're seriously affected because of most local barriers. And they are unable to recolonize isolated habitat patches because they restrict themselves to particular habitat patches and they do not venture out to other habitats because of the new barriers which are created. So the given statement is false. So B is the correct answer. Moving on to the next question. What is the full form of PES? Is it A, payments for ecosystem services, B, placement of ecosystem services, C, position of ecosystem services, or D, pollutants of ecosystem services? A. So we have another answer A. So A is the correct answer. So PES stands for Payments for Ecosystem Services. So A is the correct answer. Now, moving on to the next question, state true or false. The area people need access to for an ecosystem service to be sustainable in terms of the level of benefit they need or depend on is called a U-shed. Is the statement true or false? Here we have an answer A, another A, another A. So the statement is false. U-shed is the area people use for getting a particular ecosystem service. So this is not the correct definition of U-shed. So the statement is false. Okay. So again, definitions are important, and if you just understand the basic idea behind the definitions, you might be able to navigate all of these because the course has a lot of definitions. So if you just understand what each of these terms mean or form a visual picture of it, then you might have some sort of an deeper understanding on definitions and will be able to answer these questions more reliably. So moving on. So what is the survey technique for large mammals? Is it A, radio tracking, B, speed tracking, C, snap traps, or D, nest tubes for large mammals? A. So A is the correct answer. So for larger mammals, we have either direct observations or we have radio tracking. So A is the correct answer. Moving on. So now if we received any queries from you based on this week's content, we will address them. And also, if you have any queries, you can post them in the chat box or you can put them, just raise your hand and ask. So, if you have any queries, you can maybe raise your hand and ask or just put it in the chat box. Okay, so we received a query this week based on the content we have discussed. So, what is the difference between species richness and diversity? So, species richness refers to the number of different species which are present in a particular area or ecosystem, whereas diversity is the number of different species which are present as well as their relative abundance or evenness within that particular area or ecosystem. So richness just includes the variety of species. That is, there are if there are 10 kind of species which are there, so it will say it's a species rich area. Whereas if there are only two species in that area, so it's a species poor area. So it's not as rich. So species richness is the variety of different species which are found in that area. Whereas diversity is if you have 10 different species of having 10 members each. So that is a diverse and balanced species distribution. Whereas if you have, let's say, five species which have one members and five species which have two members, then 10 members, then that is not as diverse because their relative abundance is not even. So species diversity includes both the number of species which are there as well as their distribution. Whereas richness just looks up at the number of different species which are there. Okay, hope this answers the question. Okay, so does anybody have any questions from the participants right now? Okay, so if there are no further questions, I can then maybe close this session. So thank you so much for attending this problem solving sessions. And if you have any feedback, you can either write to us or give us the feedback in the feedback forms. And the recording for this session will be made available as a YouTube link, and these slides will be uploaded to the folder. Okay, thank you so much. Have a good evening. Thank you.